things change slightly when you deal with word problems, right? So dealing with word problems, these are the things that I would expect. Sometimes I'll ask you specifically for each step. Sometimes it's just I'm just gonna assume you're gonna go through this list, and so introduce your variables. Okay, that's important. Let me know what x and y represents, and the units as well. So I will add that to your notes here. Include units. So if it's area, is it square meters, square feet? What is it? State the implicit constraint or restriction. I'm talking about this. Okay, so this isn't easy. I usually give this half a mark. So if it's not there, you will just lose half a mark. So if that's not a big deal to you, omit it. But if you want full marks, make sure that's there. Write the inequalities presented by the question. This is important. Each restriction should have an inequality attached to it. Look at my new orange highlighter. Finally, the other one was dying on me. So if you see at least, right? Oh, there's one inequality right there. And then you keep reading, it says at most. Okay, another inequality right there. So every keyword should have an inequality listed. So then graph them, graph in 3. And I will say this. Stick to quadrant 1. Okay, stick to quadrant 1 because it's a word problem. State all the POIs, round if discrete. I will add this to x and y intercepts are also POIs now. I don't have room to add this, but I'm assuming we all know the intercept would have to be surrounding my solution region, okay? Don't just line up all x and y intercepts, okay? But that's what I mean by that. State a possible solution found in the solution region. Another term here, feasible region, right? What's feasible, what's possible, same thing. So don't let that throw you off. So I'm just giving you more terminology. So the true region is also the solution region, is also known as the feasible region, sometimes referred to as that. Okay, so these are the steps that I'm more or less going to follow on a regular basis. So we'll start nice and easy with just one inequality. Okay, just one inequality. Okay, so just so you know, when you flip through your notes, okay, these are the easy ones, right? And then we'll move on. We'll move on fairly quickly to 2 or more inequalities. Okay, a certain manufacturer makes scarves and toques. So you already know, hey, those are our 2 variables here, scarves and toques. It takes 15 minutes to produce the scarf, right? And 10 minutes to produce the toque. There is no inequality yet. It's just a fact. How much time does it take to make each one of these? Next bullet here, the company has up to 2 hours of production time available. That's what you want to highlight. Up to 2 hours of production time available. And I would circle, right, keyword. And notice that it's not going to be only the ones I've given you, right? But it says up to keyword. So that's my inequality right there. Out of this statement, I'm going to produce an inequality. Okay. Graph the solution set, state the POIs, and give a possible solution. So I will first introduce variables, right? So I'll let x be the number of scarves. And I'll let y be the number of toques. Okay, and number of is my unit, to be honest. And then I will state the implicit constraint, no implicit restriction. Please make sure that the opening, right, you're saying that x and y are greater than 0. Some students put it the other way, right? So you're saying x and y are less than 0. So now you're saying they're negative. So watch for having this the right way. All right, so let's write our inequalities. Okay, let's write them. And in this case, we're talking time. There's a restriction on time, not on how many you've produced. So we'll go 10 minutes for every scarf. And it takes us, sorry, I mixed it up, right? 15 minutes. 15 minutes for a scarf. So my bad here. 15 minutes for a scarf and 10 minutes for a troop. We're told that this, right, we can spend up to 2 hours on it. So the combination that will result of us producing scarves and tubes, we will find out what combinations are possible, has to be less than or equal to 2 hours. And we have a problem here because this is in minutes, this is in minutes, and this is in hours. So we can just say, right, 2 hours is really what? 120 minutes. I tend to convert the biggest unit into the smallest. So let's rewrite 15x. Doesn't happen very often, to be honest. But this is now the inequality where you know everything is in the same unit. That is in minutes. So this is a restriction on time available. You only have one inequality, so that's it. That's all we do. Now, the graphing part, we do just as before. We figure out our x and y intercepts. So we have 15x is equal to 120. Divide both sides by 15. I'm using this one, right? That gives me 8. It's exactly 8. 80 is my x-intercept. So sometimes it's a whole number, sometimes it's a decimal. Remember, we only use this for graphing purposes. That's why we come up with our x and y intercepts. For our y-intercept, it's 10y is equal to 120. Divide both by 10. And I'll give you another pattern or another, you will not really see the negative y scenario where you have to divide both sides by negative, flipping the sign. In word problems, that doesn't really happen. Okay, but I'm not saying it's never going to happen. Be ready for it. I might give you a problem where that is the case. But just box this in just like before. We'll rewrite. I'm actually using a lot of space. Like when I have 2 or more, I'm a lot more compact when that is the case. So 10y is less than or equal to negative 15x plus 120. So what I've done is, right, I brought the 15 that used to be on the left-hand side, I brought it over, subtracting. Then I divide everything by 10. No need to flip. And there's my inequality. You may reduce if you want, right? That would be what? 3 over 2. 5 goes in there, 3 times goes in there. But I wouldn't bother with it because if you reduce it and it's wrong, it will actually affect you, will cost you marks, right? So here we go. This is a solid line. The true region is where? Your study sheet should tell you that, right? If it's less than, the true region is below, but we're going to be shading the exact opposite. We're going to shade above because we're using reverse shading. Mr. Dirksen, but I thought we only did reverse if there are 2 or more. And I'll go back to, I don't really care what shading you use as long as you tell me what the solution region is, right? I kind of stick from now on to reverse shading. That's just what I do. Okay? So Just remember, reverse shading doesn't change the fact that the true region is below. It doesn't. Okay. So let's graph this now. Remember, quadrant 1 only. We have number of scarves and number of toques. And I have a ruler, so I'm going to use that to help me out. I'm looking at the x-intercepts here as well. If you look at the x-intercept, it goes to 8, 0 and 0, 12, right? So I'm going to go 1, 2, 3, 4, 5, 6, 7, 8. For me, that works out. Goes to 8 along the x-axis. Perfect. Here, I'm going to have to change it up a little bit. I'm going to have to go up by 2s. 2, 4, 6, 8, 10, 12. It just works. If you have to change it, you go ahead and do it. If you, yeah. Yeah. As long as you tell me where the true region is or the solution region is, yeah. But I would strongly recommend using reverse for systems because it gets messy, right? Like you don't know which one the darkest region is. So, but yeah, as long as you tell me what the solution region is, I'm fine. 8, 0 is right. So let me just label 2, 4, 6, 8, 10. No, sorry, I went up by 1, right? 1, 2, 3, 4, 5, 6, 7, 8. So for the x scale, I'm using a scale of 1. 2, 4 here, I'm going up by 2s. 6, 8, 10, 12. So just extend your line if you need to extend it. 8, 0, 0, 12. Remember, I'm sticking to quadrant 1 because I cannot have negatives. And there's your line. You label this line. You can use this one. There we go. And I told myself I'm shading above this line. So I'm going to go ahead like this. One thing that I hope you know is you can't, within a problem, do one line regular shading, one line reverse shading. You can't do that. Okay, so I told myself shaded above, this is my solution region. Remember, this one that I circled, that's what ultimately is true. The solution region is here. There we go. And it says give a pot. So the POIs, let's state them. POIs. So this is my solution region, right? So it's this one, and this one. Can you think of it this way? It's almost like your y-axis and your x-axis are also an inequality that you've drawn. Like it's like a boundary line. So this kind of surrounds my solution region now. So we've got 0, 0, this one right here. I don't need my calculator. I know this is 0, 12 up there. And this one over here is 8, 0. So you've got them all. Okay. A possible solution. Anything in here. Anything in this region. Mr. Erickson, could I have picked 0, 0? Yeah. 0, 12? Yes, you can because it's on the solid line, right? That 0, 12 is on this line. It's also on here. You could have picked any of these three, but another one could have been, let's try this, 4, 2. This is 4, 2 right here. 4, 2. That's a possible solution. That would meet the criteria you would not break the restriction. Okay, so producing 4 scarves and 2 toques is a possible solution. I will highlight that part because sometimes we forget about it. And the POIs, I'm going to give that a different color. And why didn't you stick to just your POIs as a possible solution? Because I want you to know that it doesn't just have to be the corner points. It can also be anything inside the solution region. So that point right there is my one possible solution. I want to try something else here, just so you know. Yeah, I think you need to know this. You don't have to graph. I'm just gonna. So if you wanted to type this in, you go -15 over 10 brackets x plus 12, right? So let's say you want to graph this thing. I have to adjust my window just a little bit. My y max, I'm going to go to 15. There it is, right? There's that line. Any point on this line would also be a solution. So how could you do that? You could go second trace value and just plug in any number. So you could say 5, right? When x is 5, y is 4.5. That is a bit of a problem because we can't have 4.5 of a toque, right? So you would round down a little bit so you stay within the solution region. So that's also a possibility. I think that's overkill. Like you don't need to do that. You would just pick anything from here, but it's also an option for you. All right, let's keep going. 44. I actually asked you to do this for homework. I don't know if you actually tried it and checked the key. But I think it's still worth going over and just making sure because we're going to need to heavily rely on our ability to write inequalities based on what we read. And there are little nuances here. Write the inequality for the following scenarios. Make sure you define your variables. Okay, a fridge display can hold up to 900 cubic centimeters. So X is going to be what did I put on the key? Did I go space? Space available? Yeah, fridge capacity. Yeah. Fridge capacity. And in this case, it's in cubic centimeters. So you would say the fridge capacity can hold up to 900 cubic centimeters. So that's what you should write there. Can hold up to. So you have that written like that. In order for the university to accept to offer a Spanish course, it needs at least 12 students registered for it. Okay, so let X be number of students registered. So X would have to be at least 12. So the number of students would have to be greater than or equal to 12. Okay. A farmer grows potatoes and sunflowers. So there are two things happening here. In order to profit, she needs to harvest a combined weight of 1,500 pounds. Okay. So here I would say we're talking pounds in this case. X would be potatoes in pounds, and Y would be sunflowers in pounds. And keep in mind, we're talking about both combined, okay, guys? Both combined. So then this combination, you're thinking the number of pounds combined, right, has to be, in order to profit, needs to harvest a combined weight of 1,500. Would you say greater than or equal to? I would say so. If you want to profit, you want to have 1,500 pounds or more. Okay, at least 1,500 pounds. So it could be 1,500 or more. So that's what you would put down there. A daycare takes care of toddlers and preschool children. Based on the staffing, it can accept up to 50 children combined. So X would be number of toddlers, and Y would be number of preschool children. And then you say it can accept up to 15 children combined. So the number of kids between the two categories has to be less than or equal to 50. It cannot surpass it, because that's the capacity you can accept up to. Right? So you would write it like that. Okay, let's add some more layers to this. Okay, so let's try this here. Spence, a DJ, is often hired to play at birthday parties and weddings. Birthday party usually takes about 3 hours, while a wedding takes about 5 hours of his time, including setup and cleanup. He earns a flat rate of $450 for a birthday, $625 for a wedding. So these are just facts, right? No inequalities here. Yeah, go ahead. These are just facts, no inequalities yet. But here are the restrictions. Restrictions are inequalities. If you hear if I set it up like this for you, it's like here are the restrictions coming up. You know these are inequalities, okay? Okay, let's read the first one. Spence has at most 40 hours per week available. This is a restriction on time. Okay, 40 hours available. So what would you have to do here? Let's first, we didn't define our variable. So let X be the number of birthdays, and Y would be the number of weddings. And let's not forget about our implicit constraint, X, comma, Y, they're both greater than or equal to 0. Okay. This is a must. We should have started that right off the bat. So once you've determined this, right, we're doing both. We have 40 hours available. So you would say this. There's time here. You know how much it takes you for the birthday and how much it takes you for the wedding. So you would go like this. 3x plus 5y, right? That combination would have to be less than or equal to 40. And we know that all of these numbers are in hours, right? So we're good to go. We're good to go there. We don't have to convert or do anything like that. So this is our first inequality. Okay, next. Spence would like to earn at least $2,300 a week. Let me do some highlighting here. 40 hours. We're going to deal with the hours here, correct? That's kind of what I expect you to see. And there's at least $2,300 that you want to earn. Well, guess what? You're going to go and look at those dollar amounts because they're going to give you that. Okay. So that's 450x plus 625y. You want this combination because you're going to do some birthdays, some weddings, right? You want that to give you at least $2,300. You want, whatever you do, you want this amount to be greater than or equal to 2,300. Okay, this is all in dollars, no need to convert there. Next, Spence would like to DJ at most 9 events combined per week. We're talking about the individual events here. This is as easy as this, folks. The number of birthdays and the weddings, at most 9. Okay, you don't want to have more than 9 events per week that you're spending your time on. Okay, so there are no other coefficients. It's just 1 and 1. We're talking about the number of events. Okay. Can I just circle combined? Right, like that's because sometimes students think they can kind of split it up into X and Y, whatever. No, we're talking both of them combined. We don't know how many of each we're gonna pick. Okay. Next, he would like to DJ a minimum of 2 weddings per week. Specific to wedding. Weddings only here. Okay. This is actually a very easy one to graph. So you take your wedding and a minimum of 2, right? The number of weddings, right? You want it to be 2 or more. Define your variables, then write the inequalities for all. We've already done this. Okay, this is already done. You can cross that out. And I have to tell you that sometimes I'll give you bullets like this, and you just have to like make sure there's one of each. And sometimes it's going to be just a story, and you're going to have to read out the inequalities there. But every single time there's a minimum of, at most, at least, right? Those are the things that you want to look for and create your inequalities. Okay. Are we doing okay with this so far? You might need some practice, I know. Okay. Let's go to 45. Okay. I know that some of you did the homework and you're like, I didn't know what I was doing. I copied down the answers. Right? Maybe that's what you did. Then that's fine. But knowing what we've just done now together, okay, I would like you to spend a few minutes on question 3 and come up with your inequalities. Maybe you have to make some changes to what you wrote down, but I want you to go to 45 and write inequalities for every single bullet here. Okay, and see if that makes sense to you. If you're done 3 already, go on to 4, and then I will meet you back here in a bit. Okay. Spend some time on doing those. I know you have the answers, and I know you're like, yeah, I got this, but maybe focus on how I come up with that, right? Because when you don't have the answer, some of you looked at the key and you just like, yeah, that kind of makes sense, but how exactly do I come up with it? What am I looking for? Okay, so here we go. The owner of the stand has a budget of 750, right? This actually, there's no keyword there really. But if you have a budget, like if I say I have a budget of 500 bucks on restaurants for myself every month, that means I can spend up to that, right? Up to that amount. So up to 750, that's what this statement is saying. So that's what I mean that I can't give you every single keyword. Some of them will just come across and process it as we go. For all supplies needed. So that's where you go with the cost. So I go 125 for every sandwich, and it costs me 50 cents for every hot dog. As an owner of the business, that's how much it will cost. And this has to stay less than or equal to 750, right? This will have to be less than or equal to 750. Sorry, I completely forgot to let X be number of sandwiches. We'll just make it sand for now. And the number of dogs, right? And then XY is greater than or equal to 0. And so that's our inequality there. A food stand has enough supplies to serve up to 650 sandwiches and hot dogs combined. That word, when you see that, saying, okay, the combination of both hot dogs and sandwiches has to be less than or equal to 650 because you have up to 650 in terms of space available to store all of that. The owner would like to profit at least $1,000. Now you're gonna go, it's a dollar amount, correct? So you want dollars as your coefficients. Okay, so it's $2.50 that you profit for every sandwich and $1.50 that you profit for every hot dog, and that you want that to be greater than or equal to $1,000. Okay. The owner of the stand, this is the tricky one. The owner of the stand would like to sell at least twice as many sandwiches for every hot dog sold. This is how I do this type of question. You ready? I just go Y, X like that because you're comparing the two. Okay? YX. Which one do you want to sell more of? Twice as many sandwiches as hot dogs. So you want more sandwiches, right? Twice as many sandwiches. So I'll make this, I'll make the bigger, the greater than face that way. Okay? I'll say this, want more sandwiches. So you make this the bigger, the greater than has to face that variable. These are my sandwiches. Okay, and this is where it's going to get controversial. Instinct would tell you, let's put the 2 in front of this. Instinct, right? You would say, hey, I want twice as many sandwiches. But you actually have to put it on the opposite variable on this side. Okay, so I'll use a red pen, twice as many. I'll put that right here. Yeah. Yeah, so I'm going to try my best to explain this one, okay? Let's imagine you sell one hot dog, right? Then you would plug 2 in here. Sorry. If you sell one hot dog, you plug 1 in there, and then you go 2 times 1. That would be 2, correct? So then you're saying you want this to be greater than or equal to 2. Let's say you sell 5 hot dogs, right? This would be 5, correct? You go 2 times 5 is 10. So then you're saying you want the number of sandwiches to be greater than or equal to 10, right? You want always more, like, so it's counterintuitive. It's counterintuitive, but you have to do it that way. If you want twice as many sandwiches, you got to put the 2 in front of the hot dogs. That's just how it works. Okay. Maybe we'll come across another one like this, and I'll show you. It's not very common, but I might ask you to write it out, maybe not graph it, but be ready for that. We defined variables already, we did that. Let's go over to this one. Very mindful of my time here. Canadian Tire and Wendy's. Okay. She earns $11.45 an hour at Canadian Tire, and Wendy's pays $12.50. Emily would like to work at most 30 hours. That's an inequality right there. So that's inequality number 1. Canadian Tire requires Emily to work a minimum, right? Minimum of 9 hours per week. That's inequality 2. And next is Emily would like to earn at least $225 per week. Inequality number 3. There we go. So you have to have 3 inequalities for sure. Okay. So let's see if we can do this. Define your variables. So let X be and let Y be. I think you would all agree with me that this is Canadian Tire and this is Wendy's. I think everybody would say, yeah, I totally see that. But what are my units here? Is it dollars or is it hours? Number of jobs? I would say it's number of hours, okay? It's the hours work that we're interested here. So I'll go hours, hours. That's going to be my definition here. And I'll let them both be greater than or equal to 0. It's continuous. That's probably something worth mentioning. I'm just going to write that down. It's continuous data. We're talking hours, so decimals are okay. Um, Earlier, we had hot dogs and sandwiches. You can't have decimals there. Okay, so this is, you do not round your POIs, but that's for later. Let's come up with our inequalities. Inequality 1. There's at most 30 hours per week. So that's where you go, the hours at Canadian Tire and the hours at Wendy's has to be less than or equal to 30. That's your inequality there. Inequality number 2. Canadian Tire requires Emily to work a minimum of 9 hours per week. It's only Canadian Tire, specific to Canadian Tire. So we're going to go X is a minimum of 9. Which way would it go? Like this? Right? The X, the number of hours at Canadian Tire, has to be 9 or more. And IQ 3. Emily would like to earn $225 a week. There's a dollar amount there. That's when you use the 1145X plus 1250. I have to update those hourly wages. Minimum wage is more than that already. We would like this to be greater than or equal to 225. So, right, this is dollars, hours, hours. And notice that every time we just talking about the hours, there was no other coefficient other than 1 in front of our variables. As soon as we're talking dollars, I inserted dollars as my coefficients there. So that's a bit of a pattern for you. Okay. I used to jump right in and I would just show you how to write inequalities as we went. But I think that's very important for you to be able to write inequalities. So I'm going to stop here and I'm going to give you the rest of the class to practice just that. If you go to pages 46, let me see here. I'm going to go. This is what I'm going to tell you here. Go to page 46. I'm going to say 46 to 47. You should be able to do that today. So I will say this. Define variables. Define variables. Write inequality. Sorry. I'm a little too eager here. Implicit constraint. And then write inequality. I'll give you this already. Every single question only has one inequality on 46 and 47. So it shouldn't take you that long. Graphing, right? No graphing here. My key will have a graph for every single one. This is optional. I'm not going to say don't graph, but don't worry about graphing right now. I want you to just write. I want you to be good at writing the inequalities. Because based on what I've seen, you're pretty good at graphing inequalities. It's the writing the inequalities that we need to practice. Okay, that's today. And then I'm going to step it up a bit. Page 49. I just want you to write inequalities on that one. Don't do the whole solving, graphing, I don't want you to do that. I just want you to come up with the inequalities. That one is going to be challenging, more challenging than all these ones. But if you read carefully, perhaps, you might be able to get it. I don't care if you get some wrong, but blank is not trying, okay? So you got to try. And then we'll continue tomorrow with more of this, and we'll actually solve do 2 or more at the same time.